the sine law, or how we solve non-right angled triangles, right? 'Cause most triangles probably aren't right angled triangles, and we need a way to be able to solve those. So the sine law states that for triangle ABC, remember we name angles with uppercase letters and sides with the lowercase letter of the side opposite of the same letter opposite that angle. It states that little a, or side A, the ratio of sine A divided by sine A is equal to the ratio of B divided by sine B is equal to the ratio of C divided by sine C, and the reciprocal, I can just flip it over. It says the ratio of sine of angle A divided by A is equal to the sine of B divided by B is equal to the sine of C divided by C. So depending on what you're trying to find, right? If we're trying to find, it doesn't matter which one you use, but I always like my unknown to be in the numerator. It's up top. Life is easy. You multiply both sides by something. You're not worried about dividing and flipping stuff around. And so that's why we say use this side to use this form to determine a side, and use this form to determine an angle. And you will get the sine law on your formula sheet. But let's prove the sine law, right? So we got to figure out, okay, so if we're going to use it, where does it come from? Like what justifies saying all of that? So to prove the sine law, we take triangle ABC and we're going to construct an altitude from A to D, right? So that's a perpendicular line. Perpendicular to the base BC, which is really the height of the triangle. In triangle ABD, this guy here. Oh, seriously? Okay, if we look at triangle ABD, and in relation to angle B, side H is opposite and C is the hypotenuse, so the sine of angle B is H over C. So what's an expression for H? Yeah, and the way we're going to write it, though, is C times sine B. So whenever we're writing a number or a variable times the sine or the cos of an angle, we like to put the number or variable first. Because if you write sine BC, it gets sort of confusing as to, so we write C sine B. If we look at triangle ACD, the sine of angle C is what over what? Yeah, opposite over hypotenuse, which is H over B. So what's H equal to? B sine C, right? Little b sine C. Well, since H is the same for both equations, then what can we now write? Yeah, C sine B is equal to B sine C. And if we do a little magic with that, what can we do? So we can write this a couple of different ways, right? I mean, we could divide both sides by little c. Okay, wait a second. Dividing both sides. Oh, since H is the same. What have they written? C sine B. Yeah, hang on, pause. So if we divide both sides by sine B times sine C, so in other words what we're going to get is C, I'm going to do that up here. Hang on. Go away. C sine B divided by sine B sine C is equal to B sine C divided by sine B sine C. We end up with C over sine C is equal to B over sine B. Okay. And that's 2/3 of the sine law, right? By drawing the altitude from C and using similar steps, so if you drew an altitude here and did a similar thing, you would end up with little a over sine A equals little b over sine B, which then is, of course, equal to little c over sine C. Okay? Thus, proving the sine law. Okay? So, therefore, this is true, right? And we can use that. Now, we don't use all three at once, right? We take any pair, okay? Any pair, which gives us 4 quantities. So how many of those 4 quantities do we have to know? 3, and then we can solve for the fourth. Okay, so to use the sine law to determine a missing side, we are going to use little a over sine a equals little b over sine b, right? Or whatever, right? You pick 2/3 of it. Or it could be little a over sine a equals little c over sine c, or little b over sine b equals little c over sine c. We need to know a side and its opposite angle, as well as the angle opposite the unknown side. So we need a side and its opposite angle. That's this and this. Since those are kind of paired up here, I'm going to refer to that as a known pair. Okay? We need a known pair. We need to know an angle, and we need the measure of the side opposite. Remember, SOHCAHTOA is out the window now, right? There are no right angles in this triangle. So we cannot say, oh, opposite hypotenuse, like which side is hypotenuse? Yeah, there isn't one. There is no hypotenuse. Which makes it hard to do, well, then what's opposite and adjacent, right? I mean, little a is adjacent to angle B, but so is little c, right? I mean, so there's two sides. So opposite, adjacent, hypotenuse have no meaning outside of a right angle triangle. To use the sine law to determine a missing angle, we're going to use this form, right? It's just easier. And again, we need an angle on the side opposite, right? We need a known pair. You must have a pair of letters, be they upper or lowercase, where you know both of them. I know angle B, and I know the side opposite it, little b. Okay, let's do some solving then. One page. It's going to be fairly short, right? I already did solving. Solve for x rounded to the nearest hundredth. Okay, we're solving for a side. I'm going to relabel, so let's call this angle A, and we'll call this little a, and we'll call this angle B, and that makes this little b here. And we want to find x, which is little a. We're solving for an unknown side, so we're going to use the form where the side is up top. Okay. Now you can see the problem if, I need to know 3 out of 4 of these things, and in this case, what have we got? We've got angle A, we got little b, and we've got sine of b. Okay. So little a is x over the sine of 50 degrees is equal to little b, which is 10, over the sine of 70 degrees. So actually when you're solving these, I'd like you to show the formula, right? Because besides the sine law, there's another law called the cosine law. Right? And I need to know which one you're using when you're solving things, right? I mean, today it's all sine law. All the problems you're going to do are all sine law. When we do the cosine law, everything you're doing is all cosine law, right? But in the real world, it's a mixture, right? So it's like, okay, which one are you using? And you have to figure out, okay, do I have that known pair? Do I know a pair of these guys? Then I can use the sine law. Okay, so x will become 10 times the sine of 50 degrees divided by sine 70 degrees, calculator in degree mode, and what's x to the nearest hundredth? Bigger than 10 or smaller than 10? Just look at the thing before you solve it. Is it larger than 10 or smaller? Smaller. How come? How do you know? Because what? How do you know it's smaller than 10?
15 degrees.
Yeah, it's opposite a smaller angle, right? I mean, the larger you make the angle, the larger the side opposite it, right? So the largest angle in a triangle has the largest, because you got to open up that much more, right? And the smallest angle will be across from the smallest side. And the middlest angle will be across from the middlest side. It's not actually a word, middlest. All right, what is it? What's x?
8.68.
8 point what?
6.8.
6815. 8.15 or 8.68?
6.15.
I hear more 1.5s than I hear 6.8s. Okay, two questions. One, are you in degree mode? Well, not you, but is your calculator in degree mode? Okay. Second, try again. Did you close the parenthesis after you put in the 50? Did you go 10 sine 50 close parenthesis divided by sine 70?
Yeah.
And what do you get? Okay, so we'll give you a chance to come to your own 8.15. Do it yourself. You got to see it for yourself. You won't believe other people. They're just showing you. You could have just typed in 8.15. Come on, man. Doesn't take that long. What'd you get?
8.1.
Yay. In triangle PQR, you get to draw your own triangle now, right? There's no diagram. Angle P is 63 degrees. Now, keep in mind this. When we're drawing diagrams, they are placeholders for information. They don't necessarily have to be accurate. I mean, I should be making angle P double the size of angle O. But, yeah, if I don't, you know, if I just draw some generic triangle, even if I make it right angled, right, I'm just, you know, I just want a placeholder for the information. So, but I'll try and come up with, you know, let's make angle O. I don't know. Whoops. P-O-R. Okay, so this is little p, this is little o, this is little r. Angle P is 63 degrees, this is 63 degrees. Angle O is 25 degrees. If I wanted angle R, I could get it. And little r is 12 centimeters. As a matter of fact, I need it, right? Because I need a known pair. And my known pair is going to have to be little r and angle r. So we don't have it, but we're going to calculate it, right? So what is r? What are r? What's r?
It's 92.
92?
Yeah.
Okay. So you have to calculate angle r, right? That's pretty easy because you know the angles in a triangle add up to 180. So if they give you 2, you've got all 3, right? Okay, and what do we want to find? Oh, the perimeter. That means we need both little p and little o.
Q.
I believe that's an O. Is it a Q on yours?
Yes. Yeah.
Yeah.
It's also Q, then the determinant.
Oh, it's a Q there and an O there and an O there.
Yeah, it's a
Well, it kind of makes sense, eh?
PQR.
Yeah, like POR, that's a poor choice for us. Get it? Poor choice. All right, where were we? So sine, no, sorry. We want to find little p, so it's p over sine p. Now I'm going to show you something. See, here's the thing. Like let's say we didn't have angle R a moment ago, right? So we could have said, okay, what have I got? I got angle Q, so I've got this. And I've got angle P, so I've got this. And I've got sine R, so I've got this. Well, the problem is, if I put 2 of these together, I have 2 unknowns. If I put these 2 together, I have 2 unknowns. If I put these 2 together, I have 2 unknowns. So I can't solve, right? I need that. I need this known pair in order to be able to solve, right? Having angle P, angle Q, and little r, doesn't matter how you put it together, there's always 2 unknowns. And there is not enough information to get 2 equations, because 2 equations and 2 unknown system of equations, yeah, okay. All right, so let's start off with, whoops, it's a little too thick. So let's start off with P over sine P is equal to R over sine R. Little p is equal to R sine P over sine R. So sometimes I like to rearrange it before I substitute in values, right? And then we can substitute in the values. So little p is 12 sine angle P 63. Whoops. Really? Over sine 92 degrees. So what are little p? To the nearest tenth with units. .7. 10.7 what?
0.
10.70 what?
So it's 10.6985. So
What units? Chickens per meter squared?
yes.
Oh, centimeters. All right, let's take out the Hickens and the square. Can I just erase this bit? Okay, now can I pick that up and move it? No.
You try to make
Okay.
it
10.70 centimeters, right? Because there are units, and so if there are units, you need to put them in. Everybody agree?
Yeah.
Okay, because, you know, I'm trusting him more now, but, you know, it's sort of 50-50 there. Well, I got one wrong, one right. Okay, what else? We need Q, right? So little q over sine q is equal to little r over sine r. Little q is r sine q over sine r. Little q is 12 sine whatever q was, 25, over the sine of 92, which is 5.07 units, centimeters. Okay, if there are no units, then you don't put any units down, right? Like, I mean, you know, a lot of times we just have triangles and they have a length, side length, and it's, you know, the units in that case are really just units. Okay, we good? Yes? Everybody agrees? Does that answer the question?
No.
What's the question? Oh, so what's the perimeter? Perimeter. That means we shouldn't have been rounding these guys, right? We should have kept them at least a few more decimals. What?
Q is 5.08.
5.08.
5.07. 5.45. It's 4 5. So 5.47.
5.0745?
Yeah.
It's 5.0751.
So we got
Really? 5.07. Oh, you rounded it to 2. This one gives 5.0745. So you guys have 5.0745?
No, I have 5.075.
5.0745.
yeah, 5.07.
Radius will be like so long.
She's wrong. She's wrong.
He's right by sine 62. Part of the calculation.
That's probably why.
How'd you even get that close? That's what my question would be. It's supposed to be 12 sine 25 divided by sine 92, right? Okay, anyway, so, okay, but two things, right? We're trying to work out the perimeter, which means we should carry a little bit more on these than, because, you know, if you round, you can get a rounding error. We rounded this, we rounded that, but together, maybe they, to the third decimal place, they would have bumped up a bit, and, you know, so, sorry, let's go back. What was the 10.07? What else was there? 706.
No,
No, it's
10.6985.
Oh, see, so I'm important. 6985. Yeah, and is that rounded to 4? 6985, is that correctly rounded?
I can't remember the past time. Then I did it.
69859, so let's go 6986. Okay, what was the 5.07?
5.074510.
That's good enough, right? So 4. All right, now let's add them up. So it's going to be 12 plus 10.6986 plus. So if you carry out at least a few more decimal places, and now we'll round this, what do we get?
27.7.
27.777? Or 27.8? All right. So we would have been okay, right? But just if you round to the nearest 10, if you round your intermediate answers, you do run the risk of a rounding error, which on a numeric response is fatal, right? I mean, because then it's just wrong. On a multiple choice, they're usually not, you know, 10.69, 10.70, 10. They're usually not right together. So you're going to find the one that's close. So you would be good. All right, what do we got? A few more. Solve the triangle. What does that mean?
Find the missing stuff.
Find the missing stuff. So what are we going to find?
Angle B, angle A, side column.
Okay. Do we have a known pair? Yes, we do. Okay, so then we can use the sine law, because the question in a few days is going to become, what information do I have, and am I using the sine law or the cosine law, right? Like, you know, here we know we should have enough to find that. So what's the only thing we can solve for right now? Angle A. So what am I going to write? Sine A over A is equal to what? Sine C over C. So sine A is equal to A sine C over little c. What's A equal to? The inverse sine of that. So actually when I do these calculations, that's what I like to do. I like to just cut to the chase, right? Just do the inverse sine of. Now here's what happens. If you do the sine of this, right, like if you just work this out, somebody work this out, just do A sine C, whatever, 5 sine 50 over 8. Somebody do it. 5 sine 50, close bracket, divided by 8, enter.
0.47.
0.47, right, whatever, okay. Is this likely 0.47 degrees? No. Now we know that sine values, what's the range of the sine function? Between 1 and -1. So when you get an answer here that's between 1 and -1, it's unlikely any triangle we would solve realistically would ever have an angle between 1 and -1, right? Well, first of all, it would never be negative, not in a triangle. So it's unlikely that this angle is going to be less than 1 degree. Okay? Unless that triangle is like pretty flat. Okay? Like if it's less than 1 degree, then it's almost lying right on top. That's never going to happen. Not with a side of 5 opposite that angle. We know that it's a smaller angle than this because this is a smaller side, right? So that's smaller than 50. That's all I know. So if you do it and you get an angle at 0.47, you don't write that. Oh, wait, I have the sine of angle A. I now need to go second sine, second answer to pull it in. Or right off the bat, just do sine inverse, and it'll give you a bracket. And then you're going to type in, what are you going to type in? 5 sine 50, right? And you're going to close the bracket after the 50. Divided by, you put a division, and what do you divide by? 8, and then close that. And go straight to the angle, which is to the nearest 10. How much? 28.6 degrees. Okay, what does that make angle B? So what, like 101.4? 110, 130, 180. I'm pretty sure it's 101.4. Yeah? Okay, you know how I got that? Yeah, well, it's just, I know these have to add up to 180, and I got 78.6, so that'll take me to 79, that'll take me to 80, and that'll take me to 180. Okay? And what else do we have to do? Find side little b. To get little b, we need angle b. To get angle b, we shouldn't be using 101.4. We should be using the exact values. So what we're going to do is this, right? This is sitting in our calculator. All right, first let's write out the formula. What do we need? We want little b over sine b. We're going to use the known pair, right? We're not going to go with the a. We don't want to use a calculated value if we can avoid it. And we can avoid it, right? We don't have to use this value. So we're going with little c over sine c. So little b is equal to c sine b over sine c. C is 8 sine. Now, here's what I want you to do when you're getting this angle, right? So this answer is sitting in your calculator right now, right? 28 point whatever. So you can go sine bracket, and you can go 180, don't put degree, I mean just put degree, 180 minus 50 minus second function answer, which will now give us the exact value, right, or at least 10 decimal places worth of angle B, right, and then divide by sine C. Sine, what's C, 50. And let's try it both ways. It probably won't make any difference, right? But let's see if it does. So work that out. As long as that 28.6 is sitting in your calculator, right? I mean, if you've gone on and done something else, it's not going to work that way. Okay, so what do we get for little b, rounded to the nearest tenth?
9.72.
How much?
9.7.
9.7. Is there units on that? No? Units less? It's funny. So do you all agree with 9.7? Because the answer sheet I got here doesn't, but that doesn't mean it's wrong. 10.2. That's what the answer sheet here says. So. All right, let's go with not 9.7.
10.237.
Okay, so try this. Now what I want you to do is go 8 sine 101.4 divided by sine 50. You're probably going to get 10.2, but what do you get? Still get 10.2?
Yeah.
Okay. So, but you know, keep in mind, sometimes, right, it depends on how the rounding works, you know. If you're rounding angle B to the nearest tenth and then using that in your calculation, your answer for little b may be off by a tenth, right? It just depends on how it hits. Does it hit as a 10.25 or 10.24? Okay, so in other words, we want to keep full accuracy on any intermediate calculations and round only the final answer. This is a final answer, it's okay, right? 28.6, yeah, that's what I'm writing down for that. 101.4, that is what I'm writing down for that. But to use it to then calculate, that's not what I'm writing down for that. Determine the area of the triangle shown. Rounded to the nearest area of the triangle. How do we get area of the triangle shown? Base times height divided by 2. Okay, I see a base.
You make a height.
Make a height. Draw a line. Okay.
Got that.
Like here?
Sure.
All right. So how do we get h?
Find the side. 10 of 30.
Tan of 30. H over what?
8 over magical number.
Well, it ain't 10 because 10 is this. Okay, what do we have to first find?
The base. This hypotenuse. Aside.
Aside. Aside from that, what do we have to find? Yeah, no. So if we find this side here, we will then use sine ratio. If we find this side here, we will then use sine ratio. So we need to find one of the other sides in the existing triangle in order to then we'll drop the altitude down, right? So let's unaltitude it. So what side do you want to find? This one or this one? Big one? Okay.
Big one.
So let's call this A. Make that little a. We'll call this B. We'll call this C. We'll call this B, but that would be wrong, so we'll call this B, and we'll call that little c. Okay, what formula am I going to write down? A over sine A.
B over sine U.
Really? See, and you could have found C because C's actually got the angle. I'm going with C over sine C, so I have one less calculation to do. Otherwise, I have to figure out that angle B is 80, which is actually immediately obvious, but you know, what if this was like 21.734 degrees, and this was 82.176 degrees? It's like, really, like, I don't need to calculate that, so why bother calculating it?
Because
Okay.
we don't have a pair. What?
We don't have a pair?
Yeah.
Oh, you're right, we don't.
Yeah.
Oh,
So you
so
can-
we do need to calculate. Dang.
So you are a liar. Oh!
Oh,
I'll
okay.
try for once.
Fine. Yeah. Make a note, yeah. At 9:30 on Thursday, December the 11th, Grant was right. All right, so we did have to bother calculating it. What a bother. Okay. What's that?
you get a tweet?
No. If this thing made noise every time I got a tweet, you'd never hear anything but. It were a text. Well, the furnace broke last night, so it could be related to that. So I'm just trying to. Should have come through. So you figure this out while I look, just because it might be like phone home. They want $1,000 or something. What time home? Maybe late day appointment.
Oh, damn. I did break
Uh, 3:45. All right. So what do we got? 10 sine 70 over what? Oh, sine 80. Okay, what's A? Just keep reading them off. 9.54.
That's just 9.5. 8. 8, 9.
You're gonna go with that, right? Oh, this would be a 9 then if I whatever.
8, 9.
It's
Okay, it doesn't matter because we're just gonna keep it and use it out of our calculator, right?
Yes.
So I'm just writing this down to say, yeah, okay, there it is. I'm not showing you the whole thing, but I will definitely use the whole thing in my calculation. So now, okay, what did we actually find? We found this. Okay, so now what are we gonna say? Let's call this H. Yeah, I want a formula, I want something. Sine 30 degrees is equal to
H over B.
H over A. H is equal to A sine 30. Okay, so all you got to do is go just, in your calculator, you just have to go times sine 30, right? Which gives you what? 4.771. 4.771? Okay, and what is it we were supposed to? I forgot. What are we doing in this?
The area.
Oh, the area, right? Okay, so then, what's area?
Based on height over 2.
Okay, so area is 1/2 base height. And what are we rounding to? 10th? Okay, so what is it? How much? 23.9. 23.9 chickens per meter square.
No, it's elephants.
Oh, sorry. You mean there were units with this? Oh, you didn't say so. It was actually some guy on Twitter said that, right? He says, whenever my students throw it in units, I put chickens per square meter. And so I thought, hey, that's good, right? I mean, because you have to learn to write units down, right? Like if there are units involved, you need to be cognizant and half mark aware, right? Because you don't want to lose all these half marks because you left off units. And most of the time we would take off like on a test like a half mark once for units, or maybe a total of 1 mark, but not for you guys. I mean, if there's like 5 units and you miss them, you'll lose 2.5 marks. I will take, because honest, your IBs, you should be a little more careful than regular, normal, everyday, careless students, right? So you must be careful. Solve for x, rounded to the nearest 10th. You remember, we did one like this. Remember back? We're doing right angle triangle trig. And we did the old, okay, so you're here and you look up at the flagpole 6 degrees and you back up 10 meters and you look up and it's 20 meters. We had to get all these, we had to do a lot of stuff, right? Okay, do we have to do that now?
Yes.
No.
Not really, right? Because, like we can't solve this triangle here because we don't have a known side here, right? But what can we do? Okay, and actually the way we would have done, I guess, with two right triangles or something, or I don't know, tangent. So what's our plan? What are we going to do to solve this?
Draw a line there.
Well, you could label various angles on the triangle if you wanted.
Let's do that.
All right, so what's this angle? What's this angle? What's this angle? What's this side? What's this side? What's this side? What's this side? Don't know. We don't know. Okay.
One of them is X.
So, anybody got a plan? Let me put, let's call that A, B, C, D. Okay, give me a plan in terms of A, B, C, D. What would you like to find? Well, we'd like to find AB. In order to find AB, what are we going to do? We're going to find BC. Good plan. I don't see how it's possible, but how are we going to find BC? What can we find? AC. Find AC because we've got a known pair. Once we find AC, then we can use basic right triangle trig to find x. Okay, so two-part solution, right? So we're going to use sine law. All right, so what are we using? See, I can't refer to it as angle A, because what's angle A? 30 degrees or 40 degrees?
70
degrees. No. So there's angle BAC and there's angle BAD. That's how we have to refer to it, right? We can't use angle A. It has no meaning. Okay, so we're going to use angle CAD with side CD, and we're going to solve for side AC. So this is the side we want to solve for, and it's opposite what angle?
20 degrees.
Well, you could call it angle D, but I'm going to go with sine of ADC. And that's equal to what? CD over?
Side
Okay. So this notation we don't have the sides named as such. I mean, we could if we like. We could write in this is like, I wouldn't call it little a, just because is that little a or is that little a or is that little a, right? So I would give them different names. Okay. Same thing with C, right? You can't talk about angle C. Well, is it the 60, the 120, or the 180? You could talk about angle B and you could talk about angle D because they are unique, right? There's no confusion if I say angle D. All right, so what's little AC? AC, that's what we want to find. So let's call it Y. So Y is equal to, now let's do this. Y over sine ADC, 20 degrees, is equal to CD, 10 over sine CAD, 40 degrees. Okay, so Y is equal to 10 sine 20 over sine 40. So what's Y? Sorry? 5.321. And so on, right? Keeps going, intermediate calculation, we're going to keep it in our calculator, we'll use it, and then we'll round our final answer. So how are we going to find x?
Sure.
Sine of 60? Okay, what's that equal to?
X over 80.
Sine of 60 degrees equals x. Let's call it y.
AC. I didn't like that.
We can call it y because we labeled it that. We're trying to find x, so x is equal to y sine 60. What is the exact value of sine 60, just out of curiosity? Root 3 over 2, right? You don't need to do that. You just go times sine 60 and hit enter. Okay, so. And what is x rounded to? What are we rounding to? What is x?
4.6 meters.
4.6 meters. At this
No,
point, we are rounding.
You're squared.
Okay?
Ambiguous case.
No ambiguous case, not yet.
Except for the ambiguous.
Right now.